Okay, I remain my humble self, Mr. Brown. Okay, don't forget to subscribe before watching this video. Okay, I have a problem with me here on moments. It's very simple. Okay, how will I approach this problem? I'll use the principle of what? Moments. What is principle of moments? Principle of moments is that the clockwise moments is equal to the what? Anti-clockwise what? Moments. That is what I'm going to use to approach this simple problem on the board, which students normally find difficult to what? To approach or to solve. Okay, let's proceed. What I'm going to do is that I'm going to follow the problem sequentially on the board. So let's proceed. Solution to this particular problem. Have solution on the board. The problem of solve this kind of issue is to bring out the word diagram. Once you can be able to get the diagram, you are done solving this problem. So let's quickly run down the problem on the board. A weightless bar is pivoted at its center. That means that weight is pivoted at what? Its center. That word simply means the fulcrum, okay? And weighs 10 Newton and 30 Newton and are attached on one side at 4 meter and 2 meter from the pivot. That word pivot simply means fulcrum. The weights are balanced by a weight of 25 Newton on the other side. That means this 25 Newton is the one that balanced the weight on the other side. Now see how far is the 25 Newton weight from the pivot. Okay, so let's proceed. The first thing I want to do, I'll bring out the diagram on this problem on this board. So I'll draw my ruler. The first thing I want to do, I'll bring out my ruler. I'll draw my ruler. That's called ruler. Okay. Okay. So I'll follow it sequentially now. A weightless bar is pivoted at a center. That means the fulcrum is at its center, pivoted at the center. Okay, that means from here to here is 50, and from here to here is what? 50. And now say, and weighs 10 Newton and 30 watt. That means this weightless bar weighs what? 10 Newton and 30 Newton. And are attached on one side. That means it could be this side or it could be this side. Okay, at 4 meter and 2 meter from the pivot. Very important. They say 4 meter and 2 meter from this word, from the pivot. That means from this pivot, 4 meter and 2 meter is what is applied to it. That means this first force is carrying the word 4 meter, and the second force is carrying the word 2 meter. That means, let me say from here, you want to say away from the knife edge, which is the what? The pivot or fulcrum. Let me say from here to here is my what? 4 meter. And a force of what? 10 Newton was harmed on that particular part. That means from this particular point to the particular point is 4 meter. So from here to here is 4 meter. Okay? Okay, now say what? 2 meter from the word pivot as well. That means this 30 Newton is what? Hung and go at what? 2 meter. That means, let me say from here, from this point to this point is 2 meter. Okay? So from here to here is 2 meter. 30 Newton force is also hung. That means from this point to this point is what? 2 meter. Okay? Let's proceed. From the pivot, the weights are balanced by a weight of 25 Newton on the other side. That means at this particular side. That means 25 Newton is balanced. Here is what? 25 Newton. Okay? Now see how far is the 25 weights from the pivot? How far? That means from the pivot, from this point to this point, which we don't know. That's what we are looking for. Remember, I'm going to this from here to here, that is 4. That means from this point to this point is 4 meter. While from this point to this point is what? Is 2 meter. Okay? The next thing I'm going to apply is my principle of moment. Principle of what? Moment. principle of moments. Like I said earlier, the clockwise moment is equal to the anti-clockwise moment. The clockwise is equal to the anti-clockwise. Okay, all right, let's proceed. So the next thing I'm going to do is that the clockwise moment is what? Force times distance, and the anti-clockwise moment is what? Also force times what? Distance. Okay, let's proceed. So the clockwise is clockwise. This is anti-clockwise, and this is what? Clockwise moment. Okay, so the clockwise moment, I have my 25 times my d is my x. 25 times x is equals to the anti-clockwise moment. Remember, I have two force and two distance there. So I have my what? The first one is what? Open bracket. The first force there is 10 times 4 plus. The second force there is what? 30 times 2, isn't it? Times my distance there is what? My distance there is what? Okay, I've gotten it already. Thanks, sorry about that. I have my 10 times what? 4 plus 30 times what? 2. If you have two distance, I'll have two forces there. So my 25x is equals to 10 times 4. I have my 40 plus 2 times 30. I have my 60. Okay, so my 25x equals to what? 100. Remember, I'm looking for what? X. Divide both sides by coefficient of what? X, which is what? 25, which is what? 25. Okay, 25 becomes 25. My x is equals to 100 divided by 25. My calculator. Okay, I have my 100 divided by 25. I have my 4. So my x is what? 4 meter. Okay, so I'm done with this simple problem of the board.